Hello, good day, students. Today we will continue with our lecture on data mining and big data analysis. Lecture 1, Part 2. Today we are going to review more real-life applications of data mining. We are going to look into more of the application of data mining techniques in the area of health sector, in the area of healthcare. Let's look at the applications and techniques that can be used predicting disease outbreak and patient diagnosis. We can use classification problem. We can use decision tree naive-based neural network to classify patient data into disease category. Time series analysis to monitor disease trends over time. You can use clustering techniques, K-means hierarchical clustering, to group patients with similar symptoms. Example, Google flu trends used search query to predict flu outbreak before official health reports. Identifying effective drug combination for personalized medicine. Techniques use association rule mining, a priori PF growth, to discover relationship between drug interactions. Genetic algorithm to optimize drug recommendation. Deep learning to analyze genomic data for personalized treatment. Example, IBM Watson Health uses AI to recommend personalized treatment based on patient history. Real-life application of data mining in the area of finance and banking. Applications and techniques use fraud detection by analyzing unusual transaction patterns. Technique use an anomaly detection. Isolation forest, one class CV support virtual machine autoencoder to detect suspicious transactions. Clustering, K means DB scan to group transactions and identify unusual behavior. Machine learning, random forest logistic regression, deep learning to classify transactions as fraudulent or legitimate. Example, PayPal uses AI-powered fraud detection to analyze billions of transactions in real time. Credit scoring for loan eligibility and risk assessment. Regression analysis. Logistic regression, linear regression can be used to predict loan default probability. Decision tree and random forest to assess risk level based on credit history. Support vector machine to classify high risk and low risk borrowers. Example, fiscal credit scores use machine learning to predict an individual credit worthiness. In the area of retail and economies, applications and technique recommendation system. Example, Amazon suggesting product based on browsing history. Collaborative filtering, user-based and item-based filtering to recommend product based on past user behavior. Content-based filtering, TF-IDF, casting similarity, suggests product based on product features. Deep learning, neural network reinforcement learning to improve personalized recommendation. Example, Netflix and Amazon using recommendation algorithms to suggest movies and products. Demand forecasting for inventory management. Technique use time series forecasting, RMA, LSTM exponential splitting to predict product demand over time. Regression model, linear regression to estimate demand based on historical sales data. Clustering, K-means and DM scan to segment products based on sales trends. Example, Walmart uses data mining to optimize supply chain logistics and predict demand for various products. Manufacturing and supply chain. Predictive maintenance, identifying machine failures before they happen. Time series analysis, RMA, LSTM, hot winters to track sensor reading and predict failure. Anomaly detection, isolation forest one class SCV, support virtual machine encoders, autoencoders, to detect unusual machine behavior. Classification for models, random forest can be used, decision tree SVM to classify machine condition as normal or faulty. General array uses predictive maintenance in aviation and power plant to monitor equipment health and reduce downtime. Still on manufacturing and supply chain, optimizing logistics for effective distribution. K means hierarchical clustering can be used to group delivering location efficiently. Route optimization, genetic algorithm, and colony optimization are techniques that can be used to find the shortest and most cost-effective delivery routes. Linear regression, random forest regression are the regression analysis that can be used to predict shipping delay and demand fluctuations. Example, Amazon optimizes supply chain logistics using machine learning to predict delivery time and reduce shipping costs. Under cybersecurity, detecting and preventing cyber attack using anomaly detection algorithm. Autoencoder, isolation forest one class SCVM to identify suspicious network activity. You can also employ deep learning algorithms, CNN, convolutional neural network, LSTM, and JNS to detect advanced persistent threats in network traffic. Clustering, DBScan, and K-means can be used to group malicious and non-malicious activity to threat analysis. So this can be applied to this identify phishing attempt and malware threats. We can use natural language processing. LLP to analyze email content for phishing indicator. We can also use random forest naive-Bayes SVM to classify emails and websites as safe or malicious. We can also use a priori IFP growth to detect hidden pattern in cyber attack. Example, Google Safe Browsing Service using machine learning to analyze websites and detect phishing threats in real time. Still on fraud detection, these are the different algorithms that can be used. Market basket analysis. Association rule identify relationship between products. Social network analysis. Social network analysis is a data mining approach used to examine relationship, interaction, and influence pattern within social networks like Facebook, Twitter, LinkedIn, or even corporate structures. Graph theory, model users as node and their interaction as ages. So these are the different real-time applications which we are going to model. We're going to build projects on this so that you know how we can use it to make prediction for both classification and relational problems. So we have different types of data in big data analysis. In big data analysis, we deal with different types of data, not only structural data as in relational database. Understanding the differences between structural, structured, unstructured, and semi-structured data is essential for selecting the right storage, processing, and analysis technique. So the type of storage and processing or the techniques that you will use is dependent on the type of data. Structured data, as we all know that we have been using it in our relational databases. Unstructured data require AI-driven analytic and big data tools for processing. Semi-structured data serve as the bridge between the two data structures. So you look at the structured data, how it's organized for in our database classes. We have been using structured data. We use normal SQL to implement their search, store data in related in tabular form related tables, easily searchable using SQL query, follows a fixed schema, predefined structure. The structure is predefined. It is stored in relational databases such as MySQL, PostgreSQL, Oracle, and the rest of related database tools can be processed using data mining and machine learning tools. So we see examples of structured data: banking transaction, customer details, account balances, transaction history, e-commerce orders, other related table in e-commerce. They are all structural data. They are organized in tables. Storage and processing method. And MySQL, Postgre, SQL Server, Oracle, data warehouse. Example, Amazon Redshift, Google BigQuery. Processing tool, you can use SQL, normal query language for structural data. Apache Spark Pandas, you can also use it to query it. Unstructured data does not have a fixed format or predefined structure. It's often raw, difficult to categorize, and require advanced processing techniques such as natural language processing, image recognition, and other AI techniques to clean. Characteristics of unstructured data. It does not follow a tabular format. It is quite unlike relational databases, cannot easily be stored in relational databases, require big data tools like Hadoop, Spark, or NoSQL database for storage and analysis. Difficult to search and analyze without preprocessing. Very, very difficult. You are going to see in our practical class how you preprocess this data before you can apply the techniques. High volume and complexity require AI and machine learning for processing. Here we talk about big data. This is where we talk about big data. Examples of unstructured data: social media posts, all the things we have been posting in our WhatsApp, Facebook, Twitter, Instagram, they are all unstructured data. Our email and messages, text-based communication without structured formatting. multimedia file, images, videos, audio recording, scientific research paper, PDF, document in varying format, all our social media data. They are typical examples of what is known to be structured storage and processing method. NoSQL database, MongoDB, Apache Cassandra, CodeDB, Big Data Platform, Apache Hadoop, Apache Spark, AI and natural language processing tool, TensorFlow, OpenAI, GPT, IBM Watson, and the cloud. They are the data storage behind cloud computing. Semi-structured data is a mix between structured and unstructured data. Characteristics of semi-structured data: it has some level of structure, does not fit neatly into traditional relational databases, requires specialized tools like NoSQL, XML, parsers, JSON processors. Those who uh, uses a REST API must have used know how to manage and process this type of data. So these are the comparison between the three types of data we know: the feature, format, storage, query language, processing complexity, examples, and searchability. Thank you for listening.